All right, so I think we were talking about how we would go about making the customer look like they were in central office. How do we make them appear that there's not a lot of equipment out there that we have to go and upgrade? And you had a few ideas on that, Luke.
Yeah, it's pretty much like, we talked about the concept of Centrex versus PBX, where everything used to be at the customer premise. With Centrex, everything was with the service provider, making it a lot easier to manage. And in today's managed services model, you're actually forced to put highly intelligent equipment out at the customer premise. And if you have hundreds of thousands of very small branches, it becomes very costly, not only from equipment perspective, but also to manage it. So one of the ideas would be to simplify that model and provide basic connectivity that is manageable connection with a termination unit and run your services in the edge of the network, pretty much like you would do with a Centrex model, which allows you to roll out services faster, manage them better, you have more statistics, you can gather all performance information for individual customers. They can even do self-provisioning if you're set up to do that.
Yeah, it worked well the last time. I assume it'll work well going forward. Part of the problem is making that customer transparent, though, because then that access piece still has to be controlled. I mean, it's good to put something at the end point that provides transparency and simplicity, but you still got to maintain connectivity. I think that's part of what we were talking about before. How do we do that in a better way to try and maintain or reduce the cost of that access? GPON is one, of course, but not every user is going to be able to run over a GPON. There are certainly some larger bandwidth users out there, and we need to come up with simplified ways to do that. Previously, that was SONET, and the way we would do things. We need a better way to do that.
Yeah, and I think for when you start talking about larger business services, healthcare, state and local governments that want a lot of security, that have a lot of high bandwidth, hospitals that want to do a lot of medical imaging, trading back and forth, OTN can be a good access infrastructure for that as well, because then we can put up a gig pipe and it's very secure. It's we can monitor it very well. We understand the protection mechanisms that we're used to in kind of the SONET transport world, but we can get much higher bandwidths. So OTN would be one aspect of the higher bandwidth, high quality of service type connections.
For the large enterprise kind of customers as opposed to the residential customers.
And as well, even on the PON networks, at some point, you're going to aggregate all of that, and you need a low-cost way to get back to your edge, to get back to your first peering point or your IP network, and OTN may provide a good infrastructure for that as well.
Yeah, and you can make it really transparent, right? You can provide a secure connection even in an MPLS level over a non-MPLS infrastructure. You could extend MPLS all the way to the edge, but then you might again be slightly complicating that device. So it's fairly transparent there. It's really all about the ability to roll the services out on top of that. Because very often you see either a piece of equipment that supports everything from security through switching, through routing, firewalling, video distribution, what have you, or worst case, you have multiple devices to play that role. So now you have a little rack.
That's the worst one. That's what we do today, right? We've got multiple devices at the customer premise, because we usually have, today that's over SONET, where we've got a NID and then a SONET box, another SONET box at the CO, hands off to a gateway router, hands off to core routers, and all of those devices today are perhaps even on blade servers, but they're still separated. There's still a lot of equipment inside of that central office, and part of what Verizon wants to do is differentiate from the larger enterprise kind of data center to make that more user-centric. How do we improve the user experience by pushing a lot of that as close as we can to the user, but yet not all the way to the user, because there's millions of them. You can't do enough. It's one thing to do a software or hardware upgrade on core equipment. It's another to do it on end user equipment. It's just nearly impossible. It's really expensive.
Yeah, and that's where you have to look at, to what extent you can consolidate. Very often each application runs on its own appliance. So you can end up in a CO with a lot of appliances, a lot of 1RU, 2RU processors that run individual applications, which complicates your management, which complicates your service activation, complicates the overall infrastructure management, if you can start bringing these into the network layer by providing processing capabilities in those, so you do bandwidth management, you do subscriber management, but you also do application management from that perspective, you can eliminate a lot of hardware, a lot of management interfaces. What it does require, though, is a very well-established community of application developers that actually create these applications on top of that network, and the network then exposes a lot of network-related information upward towards these application developers that they can use to create applications, to create management.
But that's very similar to what the cell phone industry is, right? I mean, we have Android operating systems, and we have an innovation center where folks can come in, developers can come in, test their applications, make sure they work so that they get a stamp of approval, right. And then it can be used by any number, 93 million users in the US for our network anyway, that have access to that application, as opposed to if they were developing it for one particular hardware or software device that they had to roll out. So the model is working quite well, at least in the wireless world.
Right.
I guess what you're saying is we need to figure out how to do that in the wireline world as well.
Yeah, no, it's an excellent analogy. You have to open up the systems, and a lot of people are afraid to do so for competitive reasons, but ultimately is the only way to create an ecosystem where different people find their areas of expertise where they can contribute to the ecosystem. It's one of the reasons why we've opened up our software. We provide software developers kits that expose this type of information. We have about 500 people developing applications on it, and it's at different levels. It's at the operating system level, it's at the appliance level, and it's at the network level.
So if you're consolidating a lot of the appliances, you're consolidating, you're centralizing, right, that piece of the infrastructure. Does that then also take some of the burden off of the transport network, because you have less appliances? You have more of a centralized application model, and now maybe I can put up maybe an OTN connection or a wavelength connection between large servers, as opposed to spreading intelligence all the way to the edge of the network. Maybe that helps your infrastructure as well.
I hope so.
Yeah.
Because we can't manage it if it's all these small pipes. We do need to manage it at the big pipes, but one of the things we've been concerned about is that interaction between those two layers. Mm-hmm. Today that's been very discrete, and what we're trying to do is take a GMPLS type control plane, if you will, and how do we interface that with an IP MPLS control plane so that we can get the automation flows all the way down, because as you say, those large routers and servers and switches, if they are truly attached to the customer, then the amount of, and especially in a wireless world, in a mobile environment, a lot of that bandwidth needs may change, or resource needs may change, right. Perhaps not on a minute-by-minute basis, but on a daily, weekly, monthly basis, that is likely to change, and we want to automate that control between them, because we do have a very sophisticated control plane from a transport layer and from an IP layer, but today they don't talk to each other.
Yeah, that's another good point, and that's also an area where you see some kind of a renewed activity. GMPLS was very active in the early 2000s when we were talking about optical switching and basically have wavelength-based networking to simplify the management of the infrastructure. Now with the technology available in ROADMs, the deployment of ROADMs, we really have the opportunity to make that optical layer, that transport network, more agile, more flexible, and play a role that is coordinated with the layers above it, using MPLS, sharing information about events that are happening in the network.
And demand, right, and load.
And demand and load, yes.
Yeah. But there's an infrastructure piece there, right? There's a I guess a next generation infrastructure piece there, right? We did the SONET, and our company even did the SONET control plane. We did the DWDM control plane, but the fundamental, it's almost like it's some kind of tipping point where, okay, now we're moving towards colorless, directionless, gridless ROADMs, right, as an infrastructure, so that I don't actually have to roll, do truck rolls and put in transponders. I've got that bandwidth available. Now the control plane in the optical layer becomes more useful. OTN comes along, and now we've got this infrastructure shift. I think at this point it's much easier to inject more things like control plane into the next generation infrastructure at the same time, as opposed to trying to completely overhaul operations of an existing technology.
Right, right, because before it was patch cords, and a control plane doesn't do you any good if you've got to move a patch cord.
Yeah.
You know, it was useless.
Well, and the operations were set. You already had control of that network.
Right, it was management driven, or back office driven down into the network, or management plane driven as opposed to control plane. But you're right. The colorless, directionless, contentionless is the first time we'll have the ability to have that agility. Plug in a transponder, and now I can make it go anywhere. Or plug in a router port, and now I can make that router port appear to any other router port in that given metropolitan area, or even larger area if we want to go through intermediate transponders. So it does offer some new capability, but I don't think we've figured out how to take advantage of that yet, and that's where I think a lot of the real work is to do yet.
Now, do you see the now, and that goes to your point, right? The connection between, now you've got this pool of optical bandwidth. Now the routers want to access that optical bandwidth, and you have some kind of control plane to mitigate that discussion, right? But are the routers actually going to set up new pipes, or are they really just on-demand resizing existing pipes?
Resizing the old one or the existing ones is a lot easier. If you say it's going to build new pipes, then we need to pre-position resources, and that's been a challenge. That was
and that's very expensive.
That's very expensive. I mean, I don't know exactly how to get around that one. If one of it is colorless, directionless, contentionless stuff says, well, maybe the spare now can sit inside the card cage and is available for some of these high-demand areas. But we'd have to have the same thing on a router port where you've got a spare router port that normally would have been in somebody's truck or wherever, but it's sitting there live, connected to the network. How we go about billing and paying, and how the business case of that works, I'm not so sure. But if we had that resource available, we used to call it a floating spare. So you had the floating spare connected to the transport network. At that time, it was a DAX, so that you could get it assigned to wherever you needed it. But the principle would be identical, where that floating spare then would allow you to augment the capacity. For there's getting to be such disparity. I think you were telling me this, a lot of disparity between the peak periods and the null periods in the traffic demands, and you don't always know where that's going to be. And then of course you need to build for peak, or you have inefficient network use. So maybe that's a way to try and augment that during peak times, or to move it during peak times, but still not make it a resource that doesn't get utilized.
I think though the interaction between the application layer and the transport layer may help there is that you can actually use your capacity more efficiently. If you have built your capacity and you don't have floating spares, if you have peak demand, you can reroute it temporarily over your restoration links, or load your links a little more while you're actually provisioning extra capacity. And having the information about what is the load on individual links, are there applications that need more bandwidth, allow you to actually do that. Because you now have that flexible optical network that you can actually reroute some of these wavelengths where they have to go.
But that's a good point, that let's assume that they're not at a gigabit or 10 gigabits, they're at 100 gigabits. And if the router interface isn't channelized, so now we need to figure out how to move that bandwidth around, or do we put up static pipes at 100G? As you say, that's very expensive. That's something I think we need to figure out how we go about sharing that resource in a non-channelized world, or we try and channelize it.
Well, an OTN may help us with that as well, because you could channelize flows conceptually, right, into smaller ODU containers, right, and then be able to resize those with ODU flex and steer them. So maybe there's going to be a crossover point between that layer 3, layer 2, and the OTN layer, where we may be able to optimize some of that.
And it just means more interaction between those two layers to provide an optimized.
But how do you, as a provider, how do you operationalize that? Right, that's a huge challenge.
It's a really big challenge. But what it means is that the intelligence has to be in the network, and we have to take advantage of.
And we're very used to it, not
service
being
provider.
in the network,
Right.
Traditionally, transport.
It's been nailed up. It's been a Telcordia-driven kind of thing in the back office that says, I've got so much bandwidth between any 2 points, and that's nailed up. If I want more, I issue a service order and I provision more. If that's done in a dynamic environment, you're right.